Hello there, everybody. So, first of all, welcome to another video on Codamy. So the last time what we did was make a maze generator, and if I can demonstrate that. So what is the next thing that we want to do? First of all, I have made some small changes since the last video. So what we are doing today is we are going to find our way from start, which will be our first block, that is 0 0 from here, and then we'll pick a random position here at the bottom row, and then we'll try to find our way from here to that point. And what we are going to use for that is this A star search algorithm, and this is the Wikipedia page for A star search algorithm. If you search on Google, you can find it easily. And here is a description of how it works. Basically, it just gives a G and an H value to every block. For example, each block is this square, you can say. Each block will have a G value and then an H value, and then it will you can say compute the F value by just adding those two, and then it will try to assess whether or not it should move in that direction. For example, if I'm going here and I am standing here, it will have two ways to go, up and down. It cannot go here. It will not go back because it must have we can assume it is coming from this side, so it has two possible ways to go, one to the bottom and one to the up. But we have to give the G and H value such that if it goes up, the F value computed for this block will have to be greater than this block. So now if it is greater for this block and like smaller for this block, we will know we don't have to go up, we have to go down, because this is essentially nearer to our finish point. So that's how we can do it. And the heuristic function that I'm going to use in this tutorial or video, you can say, is basically just the distance from this blocks X and Y to the finished blocks X and Y, like straight displacement line, you can say. I'm not going to use the Manhattan distance because I don't think that will make a much of a difference in this maze. So that will be easier to just implement the straight line distance. And the G value will be I'll explain what the G value is when we get there. So let's I think we are good to go, and let's start. Before starting, let me tell you a couple of things. Also, it has an open set, it has a set that is came from, it has G score that I have already told you, it has an F score, and it has a G score. So what essentially I'm telling you here is we have to give all this information to our block first, because our block at this moment has no information like that. So we have to go to our block object or class, you can say, and then we have to give some variables that will have this information. So let's come here, let's start coding. So the first thing that we want to see is whether or not it has been visited by search algo, and initially every block will be marked as false because none of them will have to be visited by blocks, the search algorithm. Then we will have to add neighbors to every block so that it knows where it can move to. So for that, I will have array list, the same way that we did for the maze marbles. That just the how we add neighbors will be different here. So we can say maze neighbors, because these neighbors will be after we have made the maze. So it will also be the array list of blocks. Okay, so the next thing is the G value, and for the G value, if we come here, here, what is this? G score is a map with default value of infinity. So default value for every block of G is actually a very large number. We don't have infinity here. I don't think we have. So let's see how many zeros can we add to this. No errors. No errors. Okay, can I add another one? Can I add another one? Can I add another one? Okay, so it is not giving me error, but I do know that there is some limit and I don't want to count them. Let's start with this number because it is pretty large. I think that's pretty good to go. And then there is a heuristic value, and that is also have a value of infinity. Then we will give the same value to h also, and then there will be an f value, but f score, this will be computed for each block as we go along, so we'll not initialize it but declare it here. And then to have this came from a map is basically a map to know where we are coming from. For example, if I'm moving, let it finish please. For example, come on, for example, if I'm moving from this block to this block, so I have to save that information somewhere, because when I reach the finish line, I'll have to reconstruct my path from start to finish. So I'll have to save that information, that where I'm coming from on this block. So every block has to know its previous block that it came from. So we'll have a previous inside our block element or block class. We can have a map also, but I find this way easier, so we'll just implement this. So let's now go to our search algorithm and add some variables here. So the first thing that we want to do is we want to declare a couple of blocks. First will be the current, and the second will be start search block, and the third will be finish search block. So the start and finish are very explanatory. The current will be a block that we will use to search our path along the way when we go search our path. And then we will have an array list. I'll just copy this line. Basically we'll have two array lists. So the first one will be an actual path that we will construct at the end, and the second one will be searched path. So the search path is basically just to for the animation purposes, not this has nothing to do with the actual algorithm, but in order for us to see what is happening, we need this for the animation purposes. So, and then we will have a variable, because we are doing this inside. I'll be doing this inside. I'll be adding the neighbors for maze inside our my draw loop, so I'll have to have some kind of condition to check whether or not it has already added the neighbors, so that it doesn't do it over and over again. So initially it will be false. Once we add the neighbors, we will mark this as true, and then we will have another array list, and this will be our open set that is here. It will also be used to find the search algorithm itself, and then we will have some variable that will tell us whether or not the path has been found. So I think that is it for our variables. So let's go ahead and start implementing the algorithm now. So where we want to do that, first we have been doing the maze from here to here, and once the maze is finished, we'll be marking this as true, and then we will enter the A star search algorithm here. So inside this, what I want to do, the first thing that I want to do, or maybe before that, let's go ahead and initialize our blocks that we have that we have here. So we can do that inside our setup function. So the start search block will be the first one, 0 0, and we will set its visited by maze is equal to true. Actually not here, we don't want to do that here. but we want to, we also need to initialize our finish block, finish search block, finished search block. What did I, okay, so I have some spelling mistake here, let me fix that. Yeah, so we have a finished search block that will be inside the last row, and then the column will be randomly chosen. So what we can do is, so if you remember, we have the like row and columns switched because of some this loop. But what we can do is, so for the first one is the column, so we can do the parseInt function, and here we can say random from 0 to rows minus 1. So essentially what this function does is, okay, so I'll have to bring these inside the parentheses. So what this function does is finds a random value from 0 to rows minus 1, and then that random value will be converted into an integer, and we'll pick that particular one inside our last row, that is columns minus 1. So that will be declared as our finished search block. Let's go ahead and start implementing the algorithm now. So the first thing we want to do in our loop, which is the while loop, so we have done this, we have done this, we have done this. So the first thing that we want to do is we want to add the neighbors first, right? So we will have to go to the same way we did the add neighbors here. We will do it like this, and instead of here add neighbors, we'll say add maze neighbors. So we don't have that function at the moment. Let's go and implement it quickly. So if we go here, so first of all, how are we going to add the neighbors? So if you see, okay, so we have here, obviously, because we have not implemented that as of yet. So how are we going to implement the maze neighbors? We will see whether or not for example, if we are adding neighbors for this particular block, we'll see where the lines are drawn and where the lines are not drawn. Where the lines are not drawn, we'll add that side to its neighbor. For example, there's only one side for it, like this one, so we'll only have one neighbor for this, so because it can only move from here to the right side. So we'll only be adding this neighbor, and we can check that by checking whether or not it has a line between them. And if you remember, we had the walls array, and we have set that to true and false, whether or not it has the walls between these between the blocks or not. So what we can do is we can add, not this one, we can have another add maze neighbors function, and instead of checking this, what we want to do is, for this we want to say was 3. So what this means that if it has the I forgot that, I think that this was the top. If it has the top wall, oh yeah, I have it written here. If it has the top wall, if it doesn't have the top wall, we add this neighbor. And we do the same thing here. So if it doesn't have the right wall, add this neighbor. If it doesn't have the bottom wall, add this neighbor. If it doesn't have the left wall, add this neighbor. So that's how we can do that. So let's go back to our algorithm now. So once that is done, once we have added all the neighbors, what we want to do now is so this loop will be running over and over again. So what we want to do now is add the search neighbors added here. If they are not added, only then we want to check, only then we want to add the neighbors. And once we have added the neighbors, once we have added all the neighbors, what we want to do is we want to set this to true. Okay, so so that it doesn't run over and over again, right? Okay, then what we want to do then is make the, first of all we have to, like, there is a current, a node in the open set having the lowest f score value. So in the open set we had nothing, but I didn't push anything inside the open set, so we have to add to our open set first. But before starting that, what we want to do is okay, let's start. For our start search block that we initialized earlier, first of all we want to set the g value to 0, and it's also the f value will be the g value add to, no, not this, we will be having a function heuristic. We'll have a function heuristic, and this function will take 2 blocks and find the distance between the two, the straight line distance. And in this case we will have the start search block and the finish search block, and we'll add 1 to it. So why am I adding 1 to it? So if we see here, where here we have set it, for example, there we set the g score of start with 0. I've done that, and here we find the f score for start, which is only the h. For we don't need to add 1 here, but we will add 1 later, and I'll tell you why we are adding 1 later. So now we have a while loop that will be running over and over again. So essentially these are the things that we only want to do once, so we can put these also inside our here. And also since this is giving us an error, let's create the heuristic function quickly. We can go down here and we can say, what is it? This will give us a float value, heuristic function, and it will take 2 blocks, block from, block to, and then what we want to return is distance equal to 0, and we can return that distance. And how we are going to compute the distance between these two? We can compute the distance between these two by the dist function in the processing. So distance will be equal to dist, and it will be from this row and from this column to this row to this column, right? This will be the distance from both points. So what the distance function does is takes an x and two x and y's and finds the distance between those two. So we have this. Now we have a heuristic function, heuristic value here. So I think we are good to go. We are good to go inside the while loop, and yeah, I think we are good to go inside the while loop. So and I forgot to add this to our open set. Open set dot add, since it is the since it is not an array and it is a list, we have to use the add method here. Okay, now so this while loop will be running over and over again until the open set is empty. So we will be running this else over and over again, but we don't want to do this stuff more than once. That's why we have put this inside here, and we'll set this to true once everything is done. We can also do this stuff inside our setup function, but let's not do that there, because we are adding neighbors here. Maybe there will be something, but I don't think it has anything to do with the neighbors, but I think it is good to do it here because we have another algorithm running up there. So let's now have another if condition, that is if open set dot size is greater than 0. Essentially, that what this means is until the open size has anything inside it, we will be running this if condition. So the first thing that we want to do is set the least go through the open set, find the block that has the least F score, and set the current to that block. So we have to write a function that can find us the lowest F score in the open set, and we can then set the current search block to that function, to that block. Lowest F in open set, we have to write this function, and it will return us a block. Let's go and write the function quickly. So it will be returning a block, and it will not take any arguments. It will go through the open set and then find the least F score, that the block that has the least F score. So block lowest F score is equal to open set dot get 0. To start with, I'll just say that the first one has the lowest F score, and then we'll loop through block. So this is the for off loop in the Java. I think they were introduced in Java 8. So we will see if this block that we are seeing has an F value less than the one that we have already declared up here. Then we will switch we'll say the lowest, we have a new lowest F score, and we'll set that to this block, right? And once we have gone through all of the blocks, we can then return the lowest F score, and I misspelled lowest F score here. Correct that, and again, okay. What's wrong with this? Lowest F score dot F. I'll have to check the F value, and then it will just return me that. So now we can move forward. We have that, and then the next thing that we are doing is we are checking if current is the goal. So what we are checking is if current search block is equal to the finish search block. What we want to do is, for now I don't have this function. Let's just say print path found, and if it is not, what we can do then is, and we can set the variable that we had. What was the variable? I think it was path found is equal to true. So now what we want to do then is we remove the current that we have from the open set. We can do that by open set dot remove current search block, and then we go through each neighbor of the current and then do this stuff. And how can we do that? So okay, so I made a terrible mistake here. I added the add mazes neighbors function, but I forgot to add the actual array that it should add to, because it is overriding the previous neighbors a list that we had for maze, but it should not do that. It should use this maze neighbors. So here we are going through every maze neighbor inside a block inside this maze neighbors list, and we'll do this stuff. So let's go back to here, and then what we want to do is then we will say block neighbor of current search block dot neighbors, right? Let's paste this just to avoid any spelling mistakes. And then what we want to do is we have a tentative G score. Let's say float tentative G score. Let's have the same variable name. So it will be the G score of current search block dot G, and add the distance from current to neighbor. So this is the thing that I was talking about. So the distance from current to neighbor is always 1 for us, because we have nothing like no weights or anything, but in different maps you can add this distance as you want, but for us it is always 1, so we can just add 1. Otherwise you can have another function that calculates the distance between these two blocks. And let's now see if the tentative G score is less than G score of neighbor. So that is, we can do neighbor dot G. What we want to do then is we want to say the neighbor dot prev is equal to current search block, and then neighbor dot G is equal to tentative G score, and then we have neighbor dot G is equal to neighbor dot G plus, not the G here, we are calculating F, and we will then find the heuristic, the H value of that neighbor. So we'll call the heuristic function here from neighbor to finish search block. I think that heuristic block does not exist. Why? What do we have here? Heuristic, I spelled this wrong. Is correct here, and here it is wrong. So now we have this, and once we have done that, we will check whether or not this neighbor is already in the if neighbor not in open set. So we can do that just by using the contains function in the list, open set dot contains ngbr. If it does not contain the neighbor, we will add that inside our open set. And once we are done, we will just return the failure. So I think we are good to go. Am I missing anything? I think I'm missing a couple of things we have to like have a method here where when we find a path we have to do something rather than just printing it. Let's try to run it and see if it's working, and go on from there. Maze finished and path found. So it is finding the path correctly, but now we have to animate that stuff. So to animate that, let's create a couple of functions first. Let's go here. We have a function reconstruct path block current is equal to current search block and search path dot add current, and then we will go through while current is not equal to start search block, searched path dot add current, and then we'll change our current to current is equal to current dot previous, and then we will return the searched path. So what am I doing here? search. Oh, sorry, return. I forgot the return. Yeah. Okay, so what am I doing here? What I'm finding the path from the current searching block that we are searching from to the start, and we can do that by checking the previous of every start block, every current block, and returning that path. And we'll do this. We'll do the same thing for the actual path, only at this time we will have this here, and instead of this we can have finish, I think, here, right? We can have current, but we can also have finished. Let's name them differently. I'll say reconstruct search path, and this will be reconstruct actual path. And then we can go to our function that where we are doing stuff, and we can say let's do a couple of things first. Let's make our start and the finish block. Start search block. I'll create a function make rect, and I'll pass in the color for that, because I want to make the start and the finish of different colors. Finish search blocks, and for start I will make it green, and just for starters let's also make this green. So let's go to our block and add another function, void make rect. It takes in three values: int r, int g, t, int b, and it will have fill of r, g, and b, and then we will make a rectangle. Where do we want to make this rectangle now? I think we will have to make this from, let's see, I think it should be from x and y of this block, and the size will be size and size. And just to be sure we are not adding any stroke, let's say stroke, sorry, no stroke actually. And here we can say stroke and whatever the stroke was previously, which is always black. So this will be the function that will make a rectangle. And I'll also have another function that will make line, and it will have lock to it. What this line function will do is basically make a line from the center point of one block to the center point of the two block that we are calling it on. So what we want to do here is, and I want this line to be a little thicker than the stroke itself. I'll say weight, we have a stroke weight of 4 for our maze. I'm adding this stroke weight, I'm making this one 7, and the stroke color will be the RGB that I'm receiving from my calling of the function. And then the function, there will be a line from x1, y1, x2, and y2. Let's now find these x and y. So x1 will be x plus size divided by 2, right? And int y1 will be y plus size divided by 2. So this will be the midpoint of because the square is starting from x and y and has a size. So if we take the starting point, add the size to it and divided by 2, I'll have the midpoint. And the 2 is same, just only the difference is we will have the x and y value of 2 here, and this will make a line. And then we will say restore these two back to 4 and 0. I think that will be it for this function. Let's now go back to our, let's see if it is working, if we have any problems. And also let me make this 80 just so it is finished quicker. And where we have frame rate, where do we have frame rate? Let's make this 100. So we can see that we have start, we have finish. Okay, and we have start, we have finish that we drew here, and that is red. My bad, not the other way around. But as we can see that it is coming over the lines itself. So we'll take care of that later. Let's focus on animating our path. So what we can do is, first off, let's see what we can do when we find the path. Where is our condition? This is where we find the path. We set the variable to true, and then we call the reconstruct actual path. Okay, and because this will return us, this will populate our actual path array list, and then we can go through that array list and make rectangles there. And in order to do that, we can do it int 0, int less than actual path dot size -1, and we can say I++, and I made a small mistake here. I is equal to 0, and I plus should be plus. Okay, and inside this, what we want to do is draw a rectangle on every block. This is the block, and here I want to make a line, and I want to pass in the line that we are going to make the line to. So this will be actual path dot get, and this will be I+1, and then we will have to call this 2, and we'll also have to give it the RGB value, and let's give it the red value. I think, what am I missing here? Okay, so that's that, and we will also, let's try to run it. So we are now creating a line from start to finish. Now let's see if we can make the search path as we go along. Okay, so we are searching here, right? And every time we add a new neighbor, what we can do then is, after we add every neighbor, after we have run this condition from else, like this, if after we have run this everything inside it, what we can then do is we can reconstruct the search path. Reconstruct search path, and I should not have added these curly brackets. I'm not doing anything, I'm just calling this function. Okay, so that was a problem. Let's now search path, and then we can go through the search path and make rectangles along the way. And here we will have searched path, yeah, and we will make this another color. Maybe, I think this is yellow. Let's see what happens. It is returning a value. It should not return a value. Okay, there's something wrong. I++, I think should be -2, and this should also be -2 because I'm doing the +1 here. This is giving me an index out of bound. Let's see what happens. But it didn't give me index out of bound here. Why is it giving me here? So first thing that I want to say is I don't want to make lines. I want to only make the rectangle here, and then I will only call it from here to here. Let's remove, no, let's do this, run it again. Okay, there's something wrong, terribly wrong. And the point is that our rectangles are taking over, like drawing over the actual lines. So we have to draw the lines after we have done everything here. So where are we drawing lines? This is where we are drawing lines. Let's grab all of this, and after I have done this, I'll say this. I think this should be it, and I'll say okay, so it should not do this. Let me see why it is happening and get back. It seems to be working, but there is something wrong with my order, because I am drawing these rectangles of the search path over my lines of the actual path. So I'm finding where this can be fixed. But this is fixed, but what we need to have now is, we don't want to call it when the maze is already finished, right? And if path is found, and I don't want anything to happen this either, I can say, I can write an if condition here. If path found is false, only then do all of this stuff, otherwise no. Okay, so it's fixed now. Let me slow down the frame rate again to 30 and make this like 40 so that we can see it better. Let's make this 10. Let's run it. So here we are, the maze generator and the A-star search algorithm to find the way from the start to finish for that maze. So now this is the this is the search path that it is searching for now, and so you can see that it didn't search anything here or these two. From here it checked this and checked this, and only like went downwards, didn't go there, didn't go here, because it knew that going here would mean the higher F value. So, and this is the shortest path that we see here. So what another thing that I can do is, because we have already seen the inside here, can make this 10 or make this, okay, 10 is okay, and let's make this 60 and make this even finer. Let's make this 600 and make this 30. Let's see how it looks now. So it has found its way from start to finish, but you can see that it didn't search for all these blocks, not these blocks, only these blocks. But if you have a heuristic function like much suitable, then we can even make it more efficient. I only use the distance between two boxes, the straight line distance between two boxes. So that's how we can do it to the like implement the A star search algorithm on the mazes, or whatever you want to call them. I think that will be it. You can find the source code on my GitHub. Thank you. Goodbye. Take care. Keep watching.